All right, we're going to try to finish up this lesson. I think it's fairly straightforward. Let's talk about what in the world does this mean, the end behavior. Well, it's the end behavior of a function, the graph of a function. What is it doing at the ends of the graph? Okay, is basically what it's asking you to show. So I will do a quick little general example. This is not a specific function or anything. I'm just going to draw some kind of crazy looking graph. And I just want to look at the end behaviors, okay? So, again, it could look like something like this and this. See where the arrows are? Those are the ends, okay? What behavior does it have? Where is it going on the ends? So, what is it doing here? And what is it doing here? All right? I'm going to show you how we're going to mark it. So on this particular function, all right, and it is a function, correct? Passes vertical line test. And it's continuous, all right, all that kind of stuff. What is it doing right here? So here's how we're going to show this. We're going to show this in a couple directions. We're going to say as x approaches negative infinity. What does that mean? That means as this graph goes to the left. See our x values right here, correct? As our x's go to the left, where is this graph approaching? What is the end of it? Where is it going? Well, it's going what? Now, it's still going to the left, right? I mean, who knows how many curves it has? Who knows if it just keeps going down like this? But where is it eventually going, according to the arrow? It's going what? It's going down, right? Down on which axis, though? On the y-axis, okay? So as x approaches, watch, as my x goes this way, there's a point, there's a point, there's a point, there's a point, then it keeps on going, there's a point, there's a point. What is it doing towards the end of this thing? It's going down on the y-axis. It's going negative in that direction. Does that make any sense? So the function, we'll call it f of x. We could call it y since it's the y-axis, but we're kind of doing functions now. So the f of x, the function, the graph, where is it heading? It's heading straight down, isn't it? And where is that? What is straight down forever? Where is that? That's also, well, it's not just infinity. You're going down, so it's negative infinity. That's right. So as x goes to the left, where is my graph going? It's going down, and it's going down forever, okay? And so that would be negative infinity. So that's how you're going to describe the end behaviors. And that's what they're going to ask you to do, okay? They say, what do they use, the word interval? What intervals? I forget exactly how they word it. I didn't word it in my notes exactly how they do it in the book. Mia, you got it open? Not the book that you're reading. There you go, that book in your math class. So what does it say for the problems on there? It's like 20 to something, 20 to 31 or something like that. What does problem say? You said it earlier, didn't you? You asked me about it. Somebody asked me about it. Simone, was it you? Somebody asked me about it. Mia, it was you. The interval, right? You said interval. No, it's not. It's 20 to 31, right?
Yeah, but 29 to 31 is like possible.
Okay, but just tell me what the problem says to do. That's all I'm asking. For number 20. 20 to 31. No. What does it ask? Okay, it says describe the end behavior, but it uses words intervals somewhere, doesn't it?
No, on number 26 to 31.
All right, let me look at it. I thought it was be easy. I thought you had your book open. I thought you were looking at it. That's why I asked you. Let me just look at it. Okay, 20 to 25 just says determine the end behavior of the function, okay? And then 26 to 31, you actually have to graph those things and then determine the interval for which the function is increasing and which one is decreasing. Okay, now I got that straight. So the first part of it, they're just going to ask what the end behavior is, and this is what you're going to do. Okay, you're going to put this all together. You're going to say x, as x approaches negative infinity, then f of x approaches negative infinity. All right, so that's describing this end behavior on the left. All right, as x goes to the left, what is the y? What is the function doing? It's going down. That's what this is saying right here. Does that make sense? Okay. Now, what do you think is happening over here on this end? Well, as x approaches what? Positive infinity. So as x approaches positive infinity, and you don't have to put the positive, but if you want to, you can, all right? Then what is the y doing? What is the function actually doing? It's climbing what? Up and up and up, isn't it? All right, so as x goes to the right, what's the end behavior of this? Okay, the function approaches positive infinity. All right, now these infinities are different infinities. This one is going to the right, and this one is going up. Everybody got that? Same thing with this. This infinity right here, as x approaches negative infinity, that's going to the left. This f of x approaches negative infinity as well, but it's not going to the same infinity, if you can even say that. I already know if you can say that. But it's going negative infinity. It's going down. All right? So that's what's happening here. Not every function looks like this. Okay? You might have a function that looks like this. Well, actually, let's do this. I'm going to do the actual example from the book, example 3. And it says, describe the end behavior of f of x equals negative 2x cubed. Okay, and now this one looks pretty crazy. Now you might be able to graph that. You probably should be able to graph that first one. This next one, you're going to look at it and you're like, we did not learn how to graph this thing. But you don't have to know how to graph the whole entire function. And that's what's kind of nice about these problems. All you're looking at is the end behavior. And we're going to pop on Desmos in a minute. But let's just talk about this. In general, I don't have to be really specific about this because I'm not trying to graph it perfectly. All I'm trying to do is find the end behavior of this thing. All right, so let's figure out what it's going to look like. First of all, it's an x cubed. Draw in the air an x cubed function. What's that going to look like? It's going to look like one swooshes up like this and one swooshes down like that, okay? All right, but it says negative. So normally a regular, okay, a positive x cubed function would go up like this and down like that. Would you agree? But what happens when you put a negative? Instead of going up like this, what's it going to do? It's going to flip and it's going to go down like that, right? And then, again, instead of going down like this on the positive x cubed, what's it going to do? It's going to go up like this, all right? So that's basically what it looks like. Now, it is negative 2, so it's going to be squished a little bit. It'll go up a lot faster, but that's generally what it looks like. I don't care what the perfect graph looks like, what points it goes through exactly, but this is generally what's going to happen. So all I'm looking at is the end behaviors, okay? So what is the end behavior? What is it doing right here? Well, as x approaches what? Negative infinity, what is the function approaching? Positive infinity, exactly right. And that's it. I told you it was easy, didn't I? Yep, so as x approaches negative infinity, this function approaches positive infinity. What about this end behavior right here? Because there's two ends to it, right? So what is this? As x approaches what? Positive infinity. As x goes to the right, what happens to your y? Your function. That approaches what? Negative infinity. That's your end behaviors, okay? So that first little chunk of problems, that's all you got to do. What about this one, though? That's crazy. You got an x cubed, you got an x squared, you got an x, and you got a number on the end. That's right. All you do is look for the biggest one, the degree. Okay, just find the degree. What is the degree of this polynomial g of x right there? It's 3, so it's a cube function. So it basically looks like this. Doesn't look exactly like that. All that other stuff, I'm going to show you on Desmos what it looks like. It basically looks like this because of the cube. And it's negative, so we flipped everything. So what's the end behavior of this one? The same, exactly right. It's the same end behavior as this. All right, so both of these have the same end behavior. Why? Because of the negative and because of the cubed. Do you see that? I really don't care about all the other stuff. That's all I care about is right there. Make sense? Okay. What if that was to the 5th power? It's the same thing. Anytime you have an odd degree, okay? Anytime you have an odd degree, that's going to be what it is. What if it was positive 2x cubed instead? So what if f of x equals positive 2x cubed, or any number in front of there? Let's make that look like a 3. Yep, so let's just graph it just so we can visualize it for the first time. All right, so what's a regular x cubed, if you want to call it regular, positive x cubed? It's going to look like this. So what are the end behaviors of this? Let's start with the left. Again, you always start the same way. As x approaches negative infinity, then f of x, which is the graph, approaches what? Negative infinity. Okay? This one, as x approaches positive infinity, then f of x approaches what? Positive infinity. And that's it. Anytime you have an odd functions, that's what's going to happen. What if you have an even function? We've graphed these plenty of times, haven't we? So what if you had, I didn't really give you an example on it. Well, maybe a little bit. So what if this was f of x equals, I don't know, let's just make it super easy. Just call it x squared. All right, you know what that looks like, right? So what's an x squared function look like? A parabola, right? Okay. Got a little nervous right there, a little squiggly, but there you go. So how do I describe the end behaviors to this? Well, as x approaches negative infinity, what's the function approaching? Positive infinity. Okay, and as x approaches positive infinity, then the function, or the y, approaches what? Positive infinity as well. And that's your end behaviors. That works with any, what kind of number? Even exponent, okay? When your degree is even, this is what's going to happen, all right? Those are going to be your end behaviors. What if you had, let's just do it, use the same graph, just do it in a different color. What if we had a negative? What would it do to this? You guys watching? What would it do to this? It would flip it like this, okay? And then as x approaches negative infinity, what would f of x approach? Negative infinity. As x approaches positive infinity, then f of x approaches negative infinity, right? That's really all your choices. That's basically it. Yep. Let's do the last little thing. I said we're going to do Desmos. I think this is good enough. I don't think you need to look at Desmos, okay? But you could have, again, you could have like minus 3x to the 6th plus x to the 5th plus 2x to the 4th, blah, blah, blah. And it would still have the same end behaviors, okay? It would be you could do a crazy looking graph, but as long as the degree of it is a positive, then it would look like this. Or not a positive, but an even number, it would look like this. Okay, if you put a negative, it would just flip it down so that your end behaviors would be, as x approaches negative infinity, this would approach negative infinity, all right, on both of those, okay? All right, so if you see something really weird, some crazy looking thing, you're like, I can't graph that. There's no way I can figure out what the end behavior is. No, you just look at the degree. That's all you got to do. Really, really easy. Okay, let's do one more thing, talking about the intervals that it increases and decreases. This isn't much different. Okay, if you understood what we just finished doing, let's change this to white. Yeah. Yes, who? Golf. What's that? What's golf through? I don't.
It just shows you how to do the problem.
Yeah.
And it started from you need to find a derivative.
Oh yeah, well that's calculus. Yeah, that's calculus. So, like I said, the stuff we're doing is going to lead you up to that, and it's going to lead you up to derivatives and doing integration, integrals, and did you see that word in there at all? I don't know, but yeah. But we're not going to do that in here because we're just leading up to that. So we're just trying to get the concept right now, and then when you get into calculus, then you'll talk about stuff like that. All right. So let's do this. I'm going to draw another parabola, but this time we're not just talking about the end behaviors. We are talking about where it's going to increase and where it's decreasing. All right. Now, if you look at this, increasing, where is it? We're going left to right, okay? So we're going in this direction. Where is this decreasing from left to right? So if I'm moving along here, so let's say I have an x value here, okay? And then I have an x value here. Then I have an x value right here, and I get an x value right there, okay? What is the y value doing for each of those x's as I go to the right? It's decreasing, isn't it? Everybody see that? Even though you look at that arrow and you say, wait a minute, it's going up. But if I had a little point, right, a little slider that I could move up and down or left and right on the x-axis, what would happen to the y value? So my slider's right here. Where's my y value? Here. As I'm going to the right, what's happening to my y's? They're getting smaller and smaller and smaller. Would you agree? So what do you think it's doing from here to here? It's decreasing, okay? So that would be decreasing. So here's what we're going to say. So they're going to ask you, where is it decreasing? Where is it increasing? So I'm going to write, it's decreasing from where to where? Well, I could keep going forever here, right? And I get a value for y way up here somewhere. So what's happening? So it's decreasing from where? No. Look, I started here with my x, but I could have started here. I could have started here. I could have started way over here. Negative infinity. That's what we're doing, okay? We're doing positive infinity, negative infinity. So here is negative infinity. Here is positive infinity. Does that make sense? So all the way from negative infinity, all the way until where before it starts increasing? All the way to 0, right? So everywhere from, and we're going to put it in parentheses, we're going to go from negative infinity all the way to here, 0. And then it kind of turns around, and as I keep going to the right, this starts going up now. Everybody see that? So it's decreasing from negative infinity to 0, and it's increasing from where? Where does it start the increase? From 0 all the way to where? Positive infinity. We'll put a positive. You don't have to put the plus for the positive infinity. You can just put infinity, but I'll do it just so we know. And that's when it says, find the intervals that it's increasing and decreasing. That's the interval. These are the intervals right here. It's decreasing from negative infinity to 0. It's increasing from 0 to infinity. All right? What if it was, I'll use the same graph, different color. What if it was a cube function? What if it was going up like this and going down like that? All right. So now let's put an interval, and again we put it as an ordered pair. The green one. Where is the green one decreasing? Well, for every x, as I go from left to right, where is it decreasing? From actually, it's not decreasing at all, is it? From left to right, it increases, doesn't it? Even though that arrow is down, think of it this way. For every point you put right here, you get a y value, don't you? You put another, if I keep going to the right, what happens to the y's? It just keeps increasing. This thing, as I keep going to the right, that thing just gets taller and taller and taller, doesn't it? So is it even decreasing on this at all? It's not, okay? It's not decreasing, so you just say it's not decreasing. Where is it increasing? From where to where? You got it, from negative infinity to positive infinity. It would be increasing. Do you see that? Because it kind of looks like that might be decreasing because it's going down, right? The arrow is pointing down. But again, from going left to right, as I go from here to here to here to here, what is that function doing? It's getting bigger. The y is getting bigger and bigger and bigger and bigger all the way through, isn't it? Okay? I think that's all they, oh, a constant function. A constant, let's do another color. If they talk about a constant function, this would be constant. It just doesn't change. As x increases, what happens to the y? It doesn't change. That means it's constant. Okay? It stays the same, constant. All right. Let me see what else I got to do here. I think that's it. Let me just double check. I got a few things. Okay, that looks, yeah, we covered that, covered that, covered that. Yep, that is it. So I'm going to stop recording, then we'll take a look at some of the questions you might have. Oh, let me put the homework. The homework is section 3.5b, and it's page 166. And it's 20 to 31. Okay.